Hello everyone, this is a quick lecture to introduce you to the levels of evidence. What we will be focusing on is the NHMRC levels of evidence. So today's key objective of the lecture is to understand what are the various NHMRC levels of evidence, and basically the way I'll be going through these levels of evidence is in relationship to your assignment so that it becomes more familiar to you and you can identify with the subject matter. Right, so we'll get started. Alright guys, so basically we have 4 levels of evidence. So you have to go horizontally when we look at the 4 levels of evidence, and the one which are circled over here in red, these ones, these are the most applicable one to your assignments. Your assignment is on developing an intervention plan, and because of that the most applicable NHMRC level of evidence is the first one, which is in the intervention column. What I'll be doing first is to broadly introduce you to these 1, 2, 3, 4, 5 columns. Basically, what do they mean? And then we'll go in detail with the first column to help you out with your assignment. Okay. So basically, the first column over here is pretty simple. It is study designs which are related to interventions. So for instance, you may have, say, a topic as part of your assignment where you have to look at whether school lunch program interventions are successful in reducing childhood obesity, or where school lunch programs are helpful in say increasing the nutrition knowledge of children. You may have some other sort of intervention, for example, on nutrition literacy and food insecurity. So yes, basically any sort of intervention design is what we are looking at in column 1. I'm not talking about the various type of quality of studies at this stage. I will do that in a few minutes. Right now it is just telling you what is the idea behind these 5 columns. So the first column is looking at intervention studies. Alright. Now we go on to the second column. The second column says diagnostic accuracy. So meaning studies which are related to diagnostic accuracy. So what would be a good example of this? For example, we all know from your MNT1 that you have HbA1c, which is a gold standard for the diagnosis of, say, diabetes. Because you have exact cutoffs, and you know that if your blood parameters are above or below that cutoff, you have or you do not have diabetes. Okay. Then for example, you have 20-hydroxy vitamin D, serum 20-hydroxy vitamin D, which is another diagnostic parameter to identify whether you are having vitamin D deficiency or not. Alright. So this is what it means, studies which are looking to diagnose something. Alright. So how accurate is the diagnostic parameter? So when I say HbA1c is the gold parameter for diabetes, so yes, how did I come to that conclusion that HbA1c will help you to diagnose diabetes accurately? A lot of studies were done in this space looking at HbA1c as a diagnostic parameter, and that is how they came to this conclusion. Okay. So basically, overall broad picture, second column is referring to diagnostic accuracy, studies which are related to diagnosing something. Then you have prognosis. So what is prognosis? So now guys, prognosis is the likelihood of something happening in the future. So for example, when I'll tell you a fun example. Okay, so for instance, I see a lot of K-dramas, and in K-dramas, for example, if somebody has say cancer, what is the prognosis of this person living for the next 5 years or the next 1 year? Okay, so prognosis is the likelihood of something. That was a fun example, but now let me give you a more scholarly example. So for instance, few years back, I published a systematic review and meta-analysis which looked at people who were deficient in vitamin D. These people were followed for a period of time, and then you wanted to see their cardiovascular outcomes. So when you follow these people for a period of time who are vitamin D deficient, are they more likely to have CVD, say diseases in the future or not? Okay. So that is more of prognosis. What is the likelihood of something happening in the future? And now you see how many times have I used the term future. What does this indicate? This indicates that these studies are prospective, cohort in nature, longitudinal in nature. Okay. So that is what for prognosis you generally look at study designs which are prospective, cohort or longitudinal in nature, because you want to find out something in the future. So you follow these people for some period of time. Then you have the column number 4, which is related to etiology. So now what does etiology mean? Guys, basically, and yes, before I forget, please let me let you know that in this table, which is the heart of understanding level of evidence, which is very, very important for your assignment, you will see a lot of numbers over here like diagnostic accuracy. Then you have a little number 2, number 3. All of these have a lot of footnotes meaning. All right. And this table has been taken from the following reference. I'll just share that with you. So these are the explanatory footnotes behind this table. So this is the table where I copy pasted it from. All right. And these are the footnotes to this table. Please read this footnotes. This table will make a lot more sense to you, and you will end up selecting the right kind of articles for your assignment if you have a better understanding of this table. So now what is the title of this document? And your conveners have shared this document with you. It is this one, NHMRC level of evidence and grade for recommendations for developers of guidelines. All right. And I also have given the PDF of this document as part of my footnotes over here. I have a habit of pasting references to what I select in my slides. So you will find the PDF in one of these footnotes over here as part of this presentation. Okay, so I wanted to highlight that although I am explaining to you what these columns mean, what these rows mean, but if you have your own extra reading behind this, you will feel more confident. Okay, so now we go back to etiology. So now as per NHMRC level of evidence definition, what is etiology? So guys, you classify studies as identifying etiology when it is not ethical to put people just by themselves in their intervention or control group. For example, you want to see the association between smoking and cancer, and just for your study you can't make people start smoking or tell them that no, stop smoking, like it's up to them, all right, and it's their free will. So basically what you have to do in this case is, if you want to find out the relationship between smoking and cancer, you have to select a cohort of people who are smoking by their choice, that's their lifestyle, and you're following them for a period of time, and then you want to see whether they have any implications on developing cancer or not. And similarly, you're following a cohort of people who are not smoking, who have similar baseline characteristics, which is age, gender, occupation, so on and so forth. And then you see that what is the likelihood of these people who are not smoking, do they develop cancer in the future or not? Okay. So this is called etiology. When you cannot put people in intervention and control group, it is not ethical to do so. Therefore, you have groups of people who are already doing something or who are exposed to something, and then you follow them for a period of time to see the end result. For example, exposure to nuclear radiation, radioactive components and compounds. So you cannot have a control for that. You cannot push people in doing something like that. So you follow those people who are in those circumstances versus who choose not to be in those circumstances, and then you see the outcomes of that. So I hope the difference between prognosis and etiology is clear. Why? Because in both of these columns, the kind of studies you will investigate, the high quality studies that you will investigate, are prospective, cohort in nature or longitudinal in nature. But prognosis is more say practical, like vitamin D deficiency, the study which I did. Whereas etiology is something where you cannot push people into certain groups, and that's why you follow them according to their lifestyle and choices, and then you see what the outcomes are. Alright, so basically this is one of the key underlining difference between your prognosis and etiology. Then you have screening interventions. So if we talk about the most recent screening intervention is all of us at our household now have rat test. All right, so you go to chemist warehouse, you get a rat test, and that's become a daily household thing. All right, your rapid antigen test. So basically what are we saying? We are saying that we do a rat test, we find out we are COVID positive or not, and even the rat label, if you read the detailed instructions of the rat label, it's written that screening tests are highly sensitive and specific, but they are not 100% accurate. You always have some error possibly associated with it. Most of the screening tests, they are accurate to a certain degree. So they will write a disclaimer in the rat test telling that if this screening test of your COVID positive at home comes to be positive, then yes, you are very likely to be COVID positive, very likely to be COVID positive. But then you would actually have to go and do a diagnostic test to find out if you are COVID positive for sure. That is why what has the government done? If on a rat test, if you are COVID positive, you have had your multiple shots as recommended by the government, just self-isolate for 1 week, let your COVID viruses wear off, and then come back into the society. Alright, so that's like a safekeeping measure, so that not every person who is COVID positive on rat test has to go and do a diagnostic test. Okay, so always remember, screening is like a very high chance or likelihood of the person having a disease condition, and then you go on to do a diagnostic test. Alright, but yes, these are the type of interventions that come in the screening intervention, meaning when these rat tests came into the market, a lot of randomized control trials were done all over the world to ensure that rat is a good screening indicator to identify a strong likelihood of a person being COVID positive or not. Alright, so I hope that makes sense, guys, what these 5 columns mean. Alright, so first one is the quick summary. First one is intervention studies. Second one is your diagnostic accuracy, like your HbA1c, for example. Then you have your prognosis. Prognosis is like vitamin D deficiency, what is the likelihood of somebody developing CVD. Then you have etiology, like your smoking cancer. Then you have screening interventions like your rat test. So now why have I used example for each and every one of them, guys, is because when you just read this scientific terms, a lot of time they are overwhelming and they don't make sense. But if you know a good example for each of these type of level of evidence, it makes your concepts a lot more clear, especially in this early days of your learning. Okay, so now guys, what I'll do is I'll walk through each of these levels of evidence for you. Alright, always remember the basic rule is, so for example, you have level 1. Level 1 is the top notch quality evidence. Alright, so that is a very good evidence, meaning if that evidence is saying, for instance, if that evidence says that smoking is associated with cancer, then you have to respect that evidence. Why? Because that's coming from really good quality study designs. Okay, so your level of evidence basically are your level of evidence are determined by the type of study design you have. The better the quality of study design, the better is your evidence. Okay, and what are the top notch quality study designs? Of course, if this was a classroom, you would be answering, but I'll answer for you in this case, is that, as you know, randomized control trials are the top-notch quality study designs. Alright, they are the gold standard indicator. But now, as you know, that there are certain cases where you can't just do an RCT, you can't force people to smoke and then ask them to stop or force them to stop smoking, because that's just not how it works. It's not ethical. Alright, so in this case, in such prognosis and etiological cases, you have prospective cohort studies which are equally good level of evidence. Alright, so now what is level 1 evidence? Okay, level 1 evidence are systematic reviews of randomized control trials and of prospective cohort studies. Okay, so what are systematic reviews, guys? Systematic review is not like me going out doing one research on X number of people and coming and telling you the finding. Those type of studies are called original research. Okay, So when I go out there in the field and I do my research, I'm doing original research. What is a systematic review? Systematic review is when I summarize data from a lot of other people's research. Okay, so for example, in a systematic review, I may review, it's a review. So I may review, I may study 100 studies which have looked at, for example, the association between vitamin D and cardiovascular disease. So all of these are original articles. So basically your systematic review is made up of original article. Systematic review is not a new study in itself. Systematic review is sort of an essay. It is critiquing other people's work. It is gathering data evidence from other people's work who have done work in your topic of interest. Okay, therefore it is much more stronger piece of evidence because the result is not coming just from like one study. It is coming from a lot of studies which are done in the same area of interest. Okay, and when you have a systematic review of randomized control trials, systematic review of prospective cohort studies, these are the super top notch evidences out there. Okay, so for example, you have say you have 10 randomized control trials which are say looking at folic acid supplementation and cardiovascular outcomes. Okay, so these 10 randomized control trials, when I gather these 10 studies and when I write a systematic review out of it, when I see all of these 10 studies in totality, meaning are all of these studies saying that yes, folic acid has excellent results on cardiovascular outcomes, or are some studies saying that we had no associations and some studies did not see, some studies show an opposite association. So basically systematic review involves a lot of scholarship, a lot of critiquing, a lot of thinking. Okay, so your level 1 evidence is systematic review of randomized control trials or prospective cohort studies. Okay, then what is level 2 evidence? Level 2 evidence is individual studies or original articles, meaning I going out there in the field and doing one randomized control trial. I have 50 participants, I give them folic acid and I see if this has beneficial effects on their cardiovascular outcomes. So this, but I do a very good strong RCT around this. So this is called level 2 evidence. Does that make sense, guys? Is this very, very clear? Why am I emphasizing on this? Because your assignment is based on this. How is your assignment based on this? Its application we will study in the workshop. But right now just understand what is the difference between level 1, level 2, so on and so forth. So level 1 is systematic reviews of randomized control trials, prospective cohort studies, so on and so forth. Level 2 evidence is original article, one good RCT, one good prospective cohort study. Okay, so I hope that makes sense, guys. And rather than going through level 3 and 4 in this document, which would be very confusing for you, I will give you examples of each one of these so that it becomes much more clear. Okay, so moving on to the next slide. So here, guys, this is an example of level 1 evidence, okay, which is a systematic review. Now, guys, some of you may have a question that is systematic review and meta-analysis the same thing? No, it is not. You can do a systematic review and it is okay if you haven't done a meta-analysis. If you have done a systematic review of randomized control trial, a good systematic review of randomized control trial, then you are producing level 1 evidence. If you have not done a meta-analysis with this, that is okay, it is still considered level 1 evidence. So what is meta-analysis? Meta-analysis is like adding a cherry on the cake. Okay, it's like doing something better of something which is already in a good condition. So systematic review is really good, and if you do a meta-analysis on top of it, that's even superb. Okay, but meta-analysis basically, as the term suggests, analysis. It requires a lot of statistical skills. Okay, basically you're gathering all the numbers from all of these research papers who are looking at, say, vitamin D and cardiovascular outcomes. I have taken numbers from each of these studies and then I'm doing an analysis by myself. Okay, so I run a special analysis on this data and then I produce new numbers to show that if there is an association between vitamin D and CVD or not. Okay, so I do an analysis on top of an analysis which is already done in these existing papers. That's why it's like cherry on cake. Okay, so now if you see over here, a lot of recent publications will always have meta-analysis which is accompanying a systematic review, but that may not always be the case because sometimes there are certain research questions in which you can do a systematic review but a meta-analysis may not always be possible. Right now I don't want to go further than that because it will confuse you at this stage, but just remember systematic review of randomized control trials. Look where I'm hovering my mouse. This is an example of a randomized control trial systematic review. So if we see folic acid supplementation on cardiovascular diseases, a meta-analysis of randomized control trials, and they have also done a systematic review in this. Okay, so it is not just a meta-analysis. Most of the time when they say they have done a meta-analysis, if you read the document, they have obviously done a systematic review to come to a meta-analysis stage. You cannot just do a meta-analysis without doing a good systematic review. Okay, how do you know whether a paper is a systematic review or not? Well, systematic review / meta-analysis is almost always mentioned in the title. These are very high quality research and people take pride, researchers take pride in publishing such high quality research and they want the world to know that they have done a systematic review meta-analysis, so they will put it in their title. And I'll give you a typical example of myself. So this study, if you see on the right hand side, this is a systematic review and meta-analysis of prospective cohort studies which is looking at vitamin D deficiency and the likelihood of developing cardiovascular diseases in the future. Okay, so if you see, I as a researcher, I was so excited because this was my first meta-analysis. So I have clearly written over here that hey world, look at me, I have done a systematic review and meta-analysis of prospective cohort studies examining the association between vitamin D and CVD. I cannot make it more apparent to the universe that this is level 1 evidence that I am generating. So yes, I was very happy when I did this because I looked at 89 study comparisons. Imagine 89 studies which have looked at this topic, vitamin D and CVD. I summarized data from all of these studies. So that is why these are very high quality evidence. Okay, most of the time, 99% of the times, you have to register your systematic reviews with a registration body. Okay, so what exactly does that mean? It may not be very clear to you at this stage, but just take it at face value that you have to register your systematic reviews because these are very high quality evidence and basically you have a registration number around it. One of the most common registration number that you will find in these papers is Prospero. Why am I giving you these tips of identifying good systematic reviews and meta-analysis? Because this will help you with your assignment. Okay, that's why I want you to know how to identify systematic reviews and meta-analysis so that if there are systematic reviews published in your area of research, you can identify them and can select them for your assignment, therefore increasing the probability of getting good marks. Okay, then as I said, when you are doing a systematic review of randomized control trial or prospective cohort studies, this too will almost always be mentioned in your title, in your abstract. So if you see this person over there who is Lee et al., they have taken pride in what they have done and they have said that we have done a systematic review meta-analysis of RCTs, and I have said I have done a systematic review meta-analysis of prospective cohort studies. So meaning both of these are high quality level 1 evidence. Okay, so yes, again a tip over here that the kind of studies that you will be focusing on for your assignment will be ideally, you may not always have that in your research area, the topic which you have been assigned, but where possible, try to look for systematic reviews of randomized control trials that is most applicable to your assignment. Okay, so the one on the left over here, that is most applicable to your assignment, and again refreshing your knowledge. this column is most applicable to your assignment, and all of the examples that I am covering in the slides over here, they are all related to these ones to help you understand the levels of evidence most applicable for your assignment. Okay? Alright. Then you have a level 2 evidence. Level 2 evidence, as I said, is simply a singular study, one single original research out there, but it is of really good quality. So that original research can either be a very good quality randomized control trial, or else it can be a very good quality prospective cohort study. Okay, so if you remember over here, very good quality randomized control trials or very good quality prospective cohort studies. Over here you have a big blurb written, but this basically means a good randomized control trial as well. Okay, so when you look at the footnotes, it means it's a good quality randomized control trial as well. Alright, so your level 2 evidence is one singular study. It may either be a RCT or it may either be prospective cohort studies. Okay, and the ones which are most applicable to your assignment, even if they are singular studies, original research, they are RCTs. Okay, so if you see over here a single study which is there, they are looking at folic acid and B vitamin supplementation, and this is an RCT, and the risk of cardiovascular diseases among women. Okay, so what happens if you do an RCT when you give women folic acid and B vitamin supplements? Does their risk of CVD go down or not? They have tried to investigate this as a RCT. Okay, so yep, this is and see over here they haven't written yes, they have written a randomized control trial. I was going to say that if at times if they haven't written randomized control trial, guys, a biggest hint for you to identify which level of evidence is this, please read the abstract and please read the first 2 paragraphs of your method section. From there you will come to know what is this study design, and as you know, the study design defines your level of evidence. So your study design will tell you which type of level of evidence is this paper. Okay, so everybody clear? Level 2 evidence is one singular study. It could be either an RCT or a prospective cohort. What's important for your assignment are studies which are RCT in nature. Okay. Then we go on to NHMRC level 3 evidence. So this is 3.1. These are P pseudo randomized control trials. Okay. So I have given an example over here. What does this mean? It means that over here, this R means that I have randomized people. Okay, so I have randomized people into intervention group. So just see where my mouse is hovering. Okay, I have randomized people into intervention group, and this is in the control group. This X over here is the intervention. Okay, so what is but why is this not a level 2 evidence? Like if this is a single study, why is it still not a level 2 evidence? Because the people are not blinded, meaning I as a researcher know who is in the intervention group, who is in the control group. This happens a lot in your, say, nutrition education type of RCTs, where you know that who are the people who are receiving the nutrition education and who are the people who are not receiving the nutrition education. Maybe they are just receiving a leaflet on the Australian Guides to Healthy Eating. That's your control group, whereas the other group are actually receiving a structured nutrition education program. Alright. So in this sort of interventions, difficult to randomize, so therefore they are called as P pseudo randomized control trials. For example, if you just had, say, people taking folic acid, you can make folic acid into a capsule, and all the capsules are blue in color, and say you may have somebody else who is disseminating the capsule. So you as a researcher do not know if people are taking the folic acid capsule or if they are just taking a sugar pill, which is like bluish in color. Alright. So this is how, like, you know, certain studies can be randomized, certain studies cannot be randomized. So it just depends upon the research question and what the researcher is trying to investigate. So these studies would be 3.1 P pseudo randomized control trials. Okay, so you have a intervention group, you have a control group, you have randomized them, but there is just one parameter which is missing, which is these are not blinded. Okay, so you know who is in which group. Now you have NHMRC level of evidence, which is 3.2. Over here you have Over here you basically it's a comparative study with a concurrent control. Okay, so basically what does this mean? It means that you have an intervention group, you have a control group, X meaning the intervention, okay, but over here they are not randomized. Okay, so it's clearly you are just like following both of these groups. Okay, so yep, they are not randomized, and if they are not randomized there is no question of them being blinded or not. Okay, so these are the type of study designs which would be called as comparative study with concurrent control. So yes, you have a control group, you have an intervention group, but they are not randomized, they are not blinded. Okay. Then you have comparative study without concurrent controls. Over here there is no control group. Okay, you may have singular study arms. So I have taken this one example research article which shows you that in this study design you may have singular arms, and over here my apology guys, this is level of evidence 3.3. Over here I haven't changed this, so I'll change this for you in the original PowerPoint. So yes, this is level of evidence 3.3, which means if you see in this study guys, there are three groups. Group A, which is taking 100 micrograms of folic acid supplementation. Group B, which is taking 200 micrograms of folic acid supplementation. Group C taking 400 micrograms of folic acid supplementation. No control group. They just have three singular study arms. Okay. So now this is called as a comparative study group. Yes, you have comparative groups, but you do not have a control group. Okay, and obviously there is no randomization over here, there is no blinding over here, and even if there was randomization over here, if you do not know if say your participant is taking 100 or 200 microgram of supplementation, but without a control group, you just cannot say that this is a very high quality study. This is a good study, this may have good findings, but it according to NHMRC level of evidence, you cannot classify this study as level 2 evidence. Okay, so I hope that makes sense guys. So this is your NHMRC, this is your level 3.3. okay, so your PowerPoint is saved over here, so it's all good. Okay, now we progress further. So now this guys is level 4 evidence. So what is level 4 evidence over here? For example, it could be something like what you are doing. Okay, so for instance, throughout the semester you are studying, which is your intervention. We are teaching you, we are intervening you, we are hopefully increasing your knowledge, we are hopefully supporting your knowledge increase, and then you have at the end you have your conveners who are testing you to see, okay, you have learned so much throughout the semester, so how much have you learned, let's test your knowledge. Okay, so over here as you see it is a post test only. Okay, so we don't know that before this were you like always having this knowledge and there is no change, or else you actually did not know these things beforehand, and now with doing this degree, doing this trimester, you have learned so much, and actually your post test scores are really good. Okay, so these are all experimental in design, these are they are called as case series. Over here you have one group, you may even have one group which is say pre-post test, but these are all level 4 evidence because they are not randomized, not blinded, no control group, all of those parameters, high quality parameters are not fulfilled. But at the end, why does a researcher decide to do say NHMRC level 3 or 4 evidence? Many factors guys. A lot of time it depends upon the research question, it depends upon a lot of time the funding and the resources that the researchers has, and the capacity that the researcher has in doing that, and the knowledge how that the researcher has. For example, if you have a very early career researcher, they may not jump into doing a big RCT by themselves. Okay, so there are many reasons as to why researchers may generate level 3 and 4 evidence. So we shouldn't be questioning their integrity and their scholarship for that. But basically this gives you a much better understanding, I hope, regarding what are the various levels of evidence, what type of studies, what example of studies fit into each of these categories. Alright, and yes, I finish my presentation over here and the lecture, a mini lecture over here, but again emphasizing that This red color box is the one which is most important for your assignment. We will be talking a lot more about your assignment in the workshop, but I hope this lecture has given you a good introduction as to what are the various levels of evidence. Thank you guys. Thank you for your time.